Okay. So what we will be discussing is describing the storage infrastructure management and the various functions. And we will be describing the key storage infrastructure management process. Okay, so this is the chapter number 15 in your book, and it's the last chapter. Okay, first you need to know what is storage infrastructure management. All of us are familiar with the various storage infrastructures, which are like if we are using the SAN, we use the switches, the fabrics, right? The storage arrays, the host, the servers, all these become the storage infrastructure, and it's very important to manage in order to ensure the availability of the resources. Okay, so what we will be discussing is we will be aligning the storage operations and services to an organization strategic business goal and the service level requirements. Service, any company's requirement changes according to time. Even the configuration of the infrastructure can change. The capacity requirements can change. Means at one time, if organization is needing one server to store one storage array, at another time it may need one more storage array, right? So we need to manage all the storage infrastructure, right, in order to ensure the business continuity. Okay, also what we need is we need to ensure the utilization, whatever storage components that we are using, we need to ensure that we are utilizing all those components to the fullest. Okay, so what are the different operations in managing the storage? There are three: monitoring, alerting, and reporting. So let's first start with the monitoring. Now, what we need to monitor is we need to have a check on the components and the services. For what? Firstly, we need to track the performance and the availability, right? Secondly, we need to ensure that all the components, all the storage are utilized and consumed accordingly. Next, the same thing is that whatever components are using should be made available to the clients, right? And next, whatever we are monitoring, we need to generate the reports, and we also need to generate the triggering alerts, right? We need to send those alerts to the server so that proper action should be taken in that case. Also, it can help to track multiple environment parameters like HVAC. So what are the parameters that we will be monitoring? The first will be configuration. Okay, so this includes the servers which are configured to use a particular storage array through HBAs, host bus adapters, right? Next is availability will be configured. Okay, whether the resources that we are using are available to the clients, or if any of the uh, component is crashed, right? Next is the capacity. This includes the storage capacity. Okay, monitoring the storage capacity, whether it's underuse or overuse, we need more storage components or not. The next is performance. So in this parameter, we will be monitoring the response time. Okay, it should be low, and the CPU utilization. Next is the security, monitoring whether the authorized users are accessing the components, the storage, or if there is any unauthorized or some malicious person trying to access the resources. Okay, first is how to monitor configuration. So this example tells us tells us how we can keep track of the configuration changes. Okay, so a proper report is made here which keeps track of the configuration changes. So these are the compute systems, servers. Here you can see the storage systems. So these are the storage systems. So these are connected using HBA with the FC switch. Now this is the zone. You already know that the zoning is implemented to allow a particular server to access the target disks in the storage array. Okay, so these are the WW numbers. So this server is connected with the storage array using the WWN worldwide numbers, right? So here what we are doing is we are keeping track of the devices that are uh, accessing these storage arrays, so that okay, so that we keep a check on that if there is in compliance breach or not. Okay, whatever servers are accessing the storage are complying with the security or not. Okay, so this is how we can monitor the configuration. So next is monitoring the availability. Okay, in this what we need to ensure that whatever components are there in the view, like here we have the compute systems. Okay, there are three servers, h1, h2 and h3. Here we have the switches and the storage array. Each server is having two HBAs, host bus adapters, that are connected to the switches. Okay, now why do we have these two switches? Is one is redundant switch. We have already talked about this. In order to ensure the availability, what we can do is we can make the copies of the component. We can have two storage systems. Okay, like in case we have the hot drives, when we are implementing RAID, hot disks, hot spares, right? If any of the disk fails, we can use the hot spare. So this switch right now is acting as a redundant switch. If this fails, availability is ensured, but the failure of this particular switch can lead to, if both of the switches fail, then there will be not any redundant switch, right? So it can lead to the unavailability. So we need to ensure the availability by monitoring. If there is no redundancy, then there will be no availability for that particular case. Here you can see, so this particular server is also connected to switch 2, so it can access. But if both of the switches fail, then there will not be any availability. Next is monitoring the capacity. In this case, what we will be checking out is whether the capacity, the storage that we are using, is in use or is falling, right? So here you can see, so this is the NAS file system. So this is the used capacity and the free capacity. Okay, so what we do is, in whenever we are monitoring the capacity, when the capacity is 60, means when the storage is 66% full, then a notification is sent, right? Then if it is becoming 80% full, then also another warning is sent to the host, right? So that host can manage and it can arrange some more storage, and thus the file system can be expanded. Okay, so in that case we need to monitor the storage as well, so that the system goes freely. Next is monitoring the performance. Okay, so in this case, what we will be evaluating is how efficiently the infrastructure components and the services are performing. Consider this example. Here we have the three servers, H1, H2, and H3. These are the two switches and the storage system. So these three, okay, also check this diagram here. What we have is, this is a port utilization. So these three servers are using this particular port. So, okay, this port. These three are using this particular port. Okay. Now, in this case, the green shows, so this is the limit. Okay, this is the maximum utilization, right? So if these three servers are utilizing this particular port at this level, then we cannot add more servers. We should not think about adding more servers in the system. Okay, if these three servers are utilizing this much of the total, utilizing this much of the performance, then we can think of adding a new compute system, okay, which can access that particular port in order to balance out the utilization, right? So this is what we're saying. If it is if these three are using this much, then we cannot add another compute system. But if it is in utilizing according to this green line, the combined form, not individually, the combined H1 plus H2 plus H3, then this should not be configured, some new system. So how do we measure the performances? Like if you're using Windows, you can also check out that in Windows we have the task manager where we can monitor the processes going on. Like if there is some heavy software, we can check out the what that particular, what amount of the CPU performance that particular software is utilizing, right? But in that case, in data centers we cannot just use those, so there should be some monitoring tools that can help track the threads, the processes, and this what is the utilization, okay, what those servers are, how much amount of CPU performance those servers are utilizing. So proper monitoring tool should be used by the companies. Next we have is monitoring the security. Okay, in this case, you consider that we have two work groups, work group 1 and work group 2, and these are the storage system. Okay, and so these two disks are of work group 2, and these two disks are of work group 1. Okay, these are connected with two HPAs each with the switches, right? Now, according to the security, if we do not breach the security, group 2 should only access these disks and group 1 should only access these disks. But it can happen that group 1 is trying to replicate the data lying in the disks of group 2 on its own disks. Means this group 1 is trying to steal group 2's data on group 1's disks. So this should be monitored. These kind of actions should be monitored to ensure the security, that because group 1 is not authorized to access these two disks. Okay, so we should not allow any unauthorized user. Okay, this particular group should not cause any service denial of service attack, right? So these kind of breaches should not be carried out, should not be allowed to be carried. Next is alerting. So this is simple. Whenever we are monitoring the storage infrastructure regarding capacity, performance, security, we need to provide the information regarding any threat or issue to the administrator so that they know the status of the components, the processes, and the services. Okay, what kind of alerts can be sent? The first is information, warning, and fatal. Information is just providing the useful information, right? So this does not require the administrator intervention, like creating of zone or logical unit number, then creation of new storage pool, right? Sometimes we also, whenever we are using some tools, we also get some information like you should update your system, this system requires an update, right? So that is also kind of information. Next is warning. Warning, in that case, we require administrative retention. Means action should be performed in that case. Action is must to be performed, like when the storage pool is full, so that the administrator arrange one more storage error in that case, right? Any other media errors or so on. So on, right? So third one is fatal, so which requires immediate attention. So this one can be halted like for 1 day, maybe depends on the scenario, but in this case, orchestration failure, right? The series of steps which are performed to manage the components, if that failure occurs or service failure occur, immediate action need to be performed. So these three kinds of alert should be sent to the administrator in alerting. Okay, simple. Third one is reporting. So reporting means we keep the information, we gather the information about the various components or the processes, right? And we generate reports. So the commonly used reports are capacity planning report, configuration and set management, chargeback report, performance and security breach report, right? So these are very simple. In this you will see the chargeback report. so that you understand what is the meaning of reporting. So what we usually do is we usually create a report of the capacity that is being used. So I'm explaining this one, the capacity that is being used by the servers. Okay, so for this, consider these two servers. This is payroll one compute system, this is engineering compute system. These reports are made by the managing team. This is about, just a minute. So these are the processes, these can be followed up by the companies or organization to ensure that their software infrastructure are managed. Okay. So here, so here you can see, so these are the independent of each other, right? And executing, this system is executing its own application, this system is executing own VM operating system and apps, right? So this is the production storage system that these two servers are using. Here you can see payroll. Okay, let's consider for payroll compute one. So this is using 50 GB, means 100 GB storage, right? And it's using 100 GB for local replication. Okay, and then it's using 100 GB for remote replication. Fine. Now, what we need to do is whenever we are creating the chargeback report, first we need to check the utilized. So this particular server is utilized how much of storage, and what is the total amount of storage given? What is the total amount of raw storage given, provided to that particular server? And then the chargeback cost is estimated according to that, according to the cost. For this case, we will be considering $5 per raw GB. Okay, so what we will be considering in chargeback report, firstly the storage utilized by the server plus the raw storage. Okay, so for payroll one, the storage which is used is 100 GB, you can see, and the production storage raw GB provided to that is 200 maybe. Okay, it's not mentioned here, but the raw storage provide in GB is 200. It's utilizing using 100 out of that, maybe this is extra. But in the chargeback report, we need to mention that. And the local replica is having using 100, so that's 100. And the remote replica is using 125. So that will be the 100 plus 25 extra, right? So the total raw becomes 425 in this case. So the chargeback is calculated by multiplying by the $5. So this is just about estimating the total chargeback cost, in which we also include the raw GBs. Okay. So this just ensures that how much storage will be used by that particular. Similarly for the engineering compute, now you can have a look, like similarly we can also make create the performance report where we write like how much utilization has been used by, how much CPU has been used by a particular application in the server, right? And so security breach, we need to ensure that the servers only which are authorized are accessing the particular information. So everything in the reporting, we make these kind of reports as I've explained in the chargeback reports. So next is operation management. So in which we have the configuration management, capacity management, performance, availability, and security. So here you can see first is the configuration management. So what we need to maintain here in this, all the configuration items, right? Maintaining information about those. Okay, so what is all the attributes, like whatever the configuration item we are using, its names, the manufacturer, serial, license, version, all these information needs to be maintained. The used and available capacity, issues, and interrelationship, right? What kind of like storage pool to service, storage system to storage pool, the configurations, the WWN numbers. Okay, these are unique for each storage infrastructure element, unique for storage array and for the server having HBA. So these need to be saved as an information. Next is the capacity management, as I've already explained. So this include the determining the amount of storage, right? Capacity utilization and the capacity consumption, right? And the plans for additional capacity. What if any organization runs out of the capacity, then the trends and the plans, whatever needs to be done by the business in order to ensure that the capacity is in accordance to the information that they are storing. So what can be the adding new nodes? What if they need to scale out, adding new nodes, right? So for that, what should be done in case of storage system, right? So extending the pools, setting a threshold, what should be the maximum utilization for a particular pool. So all these terms are in the capacity management. Then we have the performance management. Performance management, we ensure that uh, the response time is less and the throughput what we are using for that particular CPU is more, right? And identifies the components that are performing below the expected level. So there can be the case when some of the components are not meeting the required level of performance, right? And makes configuration changes to optimize performance and address issues. Okay. So next is the availability management. Availability means we want to provide access to the applications in no time, in less time, means we want to make the applications available. Okay. And in this case, what can be the example is we can deploy redundant, fault tolerant and hot swappable components, right? If any of the component fails, we should have the redundant or any other component which can tolerate the faults, right? Deploying compute clusters. In case of compute cluster, failure of one compute device can be handled by the other compute devices in that cluster, right? Designing multiple availability zones. Okay, like suppose one server is trying to connect to the storage array. So instead of having just one zone, we can design multiple zones for one server. Right. Next is data backup and replication solutions, as you are already aware of these two. You have any doubt? Next is security management. Next is security management. In this, we develop the information security policies, right? So as you already know, I've discussed this in previous video also. In case of security, what we need to ensure is we need to ensure no authorized person uh, is accessing the storage, or unauthorized, sorry, no unauthorized person is accessing the storage. When we have multiple servers, right, in the design, so what we want to do is we only want to, if there are administrators accessing, so there should be role based access. Okay, administrators should only be able to access uh, the administrative tasks, right? The groups and users should be able to access the applications that they're authorized, so which is implementing role based access. Secondly, configuring, important thing is configuring zoning and LUN masking. Like when one server is trying to connect with the storage array, so that server should only be that server will be having its own logical unit number and should only be accessing its own logical unit. And in case of zoning also, we create zones, right? And one server should be able to access the storage array which is in that particular zone. And data encryption services, encrypting the data. Next is we can scan the applications to identify any kind of vulnerabilities. If we can see that this particular component can face a threat, so particular follow-up can be made in that case. And deploying controls and multiple level defense in depth to access the data and services, right? So this includes that using multiple levels of security. This is why it's called as defense in depth. So using multiple security levels in order to ensure the security. So last topic here is information lifecycle management. Okay, so the main idea of having this topic is that information, what is the lifespan of information? Like, what do you think? When is the information most important? When the information is new, and if someone is accessing that information, then we can say that the information is of importance, is of significance, right? So what is written here is, when information is first created, it is often has the highest value and is accessed frequently. As the information ages, it is accessed less. And according to that information life cycle management, I'll show you the diagram for this. Like, so this is the sales order information. Here you can see when the order is new, means this is the order has been created, so this is in use, right? And then we are accessing the order, so this is also in use. The information is of importance. Processing the order, delivering the order, and when the order is fulfilled, okay, until the user can claim any kind of warranty. Okay, once everything is done, right, then when the data is aged, then simply the data is archived and then the disposed. So this becomes the information life cycle management. Okay, why we are studying this is, so what can be done in this case is, companies can use the different strategies to deal with the information. Okay, the first is the total lower total cost of ownership by aligning the infrastructure management cost with the information value, right? So as a result, resources are not wasted. So what we can do is, once we reach this particular level, so this can be disposed. We should not keep this information. So this is just utilizing the storage. Simplified management by integrating process steps and interfaces with individual tools, and by increasing automation, maintaining compliance, knowing what data needs to be protected and what length of time. Okay, so any organization can have its own set of policies that they will be keeping or saving the data for this much amount of time, and which data they should keep for a long time, right? Next is optimized utilization by deploying storage tiering. So this is important. uh, how we can save the data in the tired storages, we can have, we can divide our storage components in two tiers, tier 1 and tier 2. In tier 1 we can have uh, high-end storage like ssd drives, right? And in the tier 2 we can have low means not much expensive storage like hard disks, right, or tape drives. So what we can do, once the information is saved, we can save the information in tier 1, which is ssd drives, right, or fault tolerant drives. Once we reach a particular time, like suppose after 30 days or after 60 days, we think that the information is now aged and it's not required to be saved in that tire, we can then shift that to the another tire which is low end, or it's not that much expensive. Okay, so that was about storage tiering that can be deployed for optimized utilization. So this was about this topic. So it is easy. So I hope this was useful.